I'm Alex Demakis, as we said. I'm teaching here in Texas. This is a project that involves about 35 people from many institutions that I'll be telling you about. It's called Datacomp. And this is the team that you can see. It involves many, many universities, industry folks, many, many students. And it is the creation of the largest multimodal data set that exists today. And I love this conference, the first time I come, but I love it because, everybody says things, that are not obvious in academia, like data is the secret, but what exactly that means and how do you do research on it or how do you do it in industry is actually quite tricky. So I'll tell you about a few things we have learned, how we made this project, this paper. This is a project, a paper, a competition on how to curate data sets. And it's also a tooling, open source tooling collection of tools on GitHub. So the first thing is people talk about foundation models, and if I say, okay, what are foundation models? Everybody says, yeah, it's like these big language models like ChatGPT, Claude, and so on, which is fine, it's true, but it's not the only thing. There's actually many, many other foundation models, like for example, StyleGAN and DALL-E and Stable Diffusion are generating images, and they can be used as foundation models. CLIP is another extremely important model. How many people here know what CLIP is? Please raise your hands. Very, very few. Okay, cool. So CLIP is two neural networks, an image to vec and a text to vec, okay? And if you want to understand, if you want to find bananas in a big data set of images, you just type an image of a banana, you encode all your images, and then you do inner product search, okay? So it's an image to vec and a text to vec, two towers. And it can be used to classify images, it can be used to do retrieval, and it's an extremely important foundation model because you can build a lot of things on top of it. When something is a foundation model, and that's kind of one of the most important ideas, it's called that because you're using it as a foundation to do something else, okay? The easiest way to do something else is with zero-shot prompting. Like GPT-4 was trained for next token prediction, but you can use it to do sentiment detection, for example, right? Just by typing a prompt. The next way you can use it is by putting a bunch of examples in the prompt. That's called in-context learning. And another way you can use it is by fine-tuning on a data set or doing LoRa or doing many fancy ways of teaching the model new tricks, okay? So it's called a foundation because you're building on top of it or using it as a filtering mechanism or as a mechanism to create synthetic data. And these are the key ideas that allow you to create these high-quality data sets. So some foundation models are generative and some are not. Some are classifiers like CLIP. And all the foundation models are trained at a different scale, at billion scale compared to previous state-of-the-art, which was million. And both millions and billions sound to me like big numbers, basically. But there is a phase transition that seems to be happening when we're getting at a new scale that enables these magical new capabilities. And most foundation models are closed. And this is a key problem for a competitive AI ecosystem. This is changing right now, gladly. The open source movement is making a big comeback, as you all know. But the other thing I want to say here is everybody's releasing weights of models, which is good, but nobody's releasing data sets, right? And if you actually want to fine-tune or do distillation or do many things with these foundation models, you need data, you need data sets, okay? And creating these, let's say, fine-tuning or distillation data sets or new data sets to do new things, you need to have a base pool of high-quality data, and that's where all the action is, I think, right now. So we need large open multimodal data sets and open models. Now we're getting open models, gladly, but we're not getting a lot of data sets. So in IFML, this IFML is an NSF institute that I'm the co-director of. It's an institute involving University of Texas and also University of Washington and a few other partners in other US universities. We are creating new foundation models and new data sets, as I will tell you today. And we also have a lot of algorithmic work. How do you teach an existing foundation model new tricks? But I won't get into that today. So data sets, as everybody here is saying, are the foundation of progress in AI. And you can see, for example, how the size of the data sets went from 3 billion tokens to 30 billion tokens to 300 billion tokens and so on. This is for GPT. And for images, just image data sets, we had ImageNet, which was 1 million images, and we consider that a large data set. but now it's considered just a baby data set to start in vision. It's amazing, actually. Now, Lion is a key part of this talk. How many people here have heard of Lion? Please raise your hand. Very few again, okay. Lion is not very well known, but it's extremely important because any multimodal model that exists, that I know of, has been trained on Lion. So Stable Diffusion, for example, or OpenClip, which are extremely widely used projects, are built because of Lion. So Lion is a 5 billion image caption data set. And another very interesting insight is every major scientific discovery that happened in AI, you can pinpoint it really to a data set, okay? So for example, MNIST, the hand-written digit recognition, was perhaps the reason that CNNs were able to prove themselves. Right? So in order for a new algorithmic idea to prove itself, it must beat the previous ideas. Right? So in order to do that, you need a new data set that actually demonstrates this win. ImageNet is the canonical example of this. When there were like very few academics working on neural networks in 2010, and the famous story is that Hinton, I think, called Jitendra Malik at Berkeley. He said, okay, what do you want me to do to convince you neural networks are important? He said, beat Pascal. Okay, Pascal was another benchmark and another data set. And Hinton said, he said, I can't do that, it's too small, but I can beat ImageNet. And said, okay, beat ImageNet. And then there was this ImageNet moment in 2012 where actually neural networks were able to demonstrate their ability. And that's when everybody started paying attention because of ImageNet, okay? So if we didn't have ImageNet, I think we would not have known that neural networks are important, and we would have ignored them the way we were, because academia didn't like neural networks at all, because they were hacky and we had no idea what we were doing as opposed to previous principal techniques. So the same thing again with OpenAI, but this is not open now. The new datasets that OpenAI is using and the new datasets that all the big companies are using, they're not releasing the datasets as far as I know, with very few exceptions. So of course the future is multimodal, so it's not only about text now, it's images and text, so you need multimodal datasets that have images and text together. So here I'm showing an example of GPT-4v, which you all know. You can put an image and ask for a prompt. Look at the CT scan of this lung and tell me what's wrong. And GPT-4v produces this diagnosis. There appears to be multiple areas of consolidation, blah, blah, blah. I showed this to doctors and they said it's actually wrong. So, but still it's pretty good and maybe it will get better. Yeah, so it's not replacing doctors just yet, but it's making good progress. So what we realized in the universities is we need large open multimodal data sets. And that's where Lion enters. So Lion was this first large open multimodal data set. We didn't create Lion. This was the step where we based our project on. It is a 5 billion image caption pair from the internet. So how the hell do you find 5 billion image caption pairs? By the way, the process I'm describing to you is also the same process that all the text data sets are created. For example, Red Pajama and Dolma and all the data sets, if you're pre-training just LLMs, it's basically very similar pipeline. You start with the internet, okay? So on the internet, there's HTML, right? And HTML points to some JPG, and you're like, okay, that's an image. Now I need some text that goes with this image. You know the alt text that is in the HTML tag? That's the text. So I'm just going to take the internet. Common Crawl scrapes the whole internet. Who knows what's in there, right? I know because we did this. There's a lot of terrible things, first of all. So you have to worry about all the terrible things you find on the internet. And another thing is, if you ask me about copyright, for example, right? I'm like, I have no idea what is copyrighted there. Some kid was doing a class project in UC Irvine. They may have scraped anything, dumped it on some website somewhere, and Common Crawl may have picked it up from there. I have absolutely no way of knowing. And by the way, that's another thing that I think is true universally. The reason I think companies are not releasing datasets is because nobody knows what's in there, okay? So that's my first insight. Because we're talking billion scale here, right? We're talking about huge, huge things. So you have this messy, gigantic starting point, which is images and text. And the key point is filtering, okay? Curation, the most important part of curation is filtering. So so dataset creation in this time is, as opposed to the previous times where you had mechanical Turkers labeling things, right? That was the old way of creating data sets. But the modern way is you start with the internet, and then you have other AI models that are looking at this messy junk you have collected and clean it up, okay? So dataset creation is a dataset filtration problem. And we used CLIP, like Lion actually, the first used CLIP, which was a model released by OpenAI, to do the filtering. And after Lion was released and created, it was used to train Stable Diffusion, OpenClip, and many, many other world-changing open projects. And it won the NeurIPS'23 Best Paper Award, but it had many problems. So Datacomp is Lion 2.0. So we basically made a better Lion. So we went from 5B to 13B, first of all, so it's larger. But the other key idea is instead of us only releasing the data set, we actually said we'll make it a competition. And the reason it's important to make a competition is you can build a community and you can release the tooling, so you can make data-centric AI a first-class citizen in research. I will explain how the competition works. What it starts is a pool that we have already cleared up. We have cleaned up a lot of things, and we start with a pool of, let's say, 13 billion image caption pairs. And the job of the competition, the job of somebody who's playing in this game is to select a subset out of this 13 billion. And now one thing they can do is they can say, okay, my choice is all of it. I keep all 13. Then we are going to train a model on this selection, and we're going to evaluate it, and we're going to tell you how good your selection is. But if somebody else comes and says, instead of picking 13B, I chose 1B, so it's a much smaller data set, now they're allowed to do 13 passes over that because the total compute is fixed, right? So the bill you pay to AWS to train is fixed. So if you make a smaller data set, you will do more gradient descent steps, okay? So that's how this game works. And the first answer is, the best thing to do is not to keep all the data. Actually, it's a tremendously bad idea to keep all the data, okay? So everything is about how do you filter, and the way you filter is you have other machine learning models that you are training using, for example, other foundations like GPT-4 to select your filtering mechanism. You can run, then we have fixed the training code, and we have fixed exactly the evaluation. You get a CLIP model, and then you're evaluating it zero shot on several tasks. And we also did a lot of cleaning jobs before that. We detected and blurred faces, which made Lion usable by many companies. Many companies couldn't use Lion because it had random images from the internet. And we also removed NSFW content, which was a lot and was terrible. And we basically did a lot of steps so that companies can use it with less liability issues. So, as I say, the key idea was to let's redo Lion, but in a flexible and reusable way. And not only publish the data set, but also the entire tooling around the data set, and make it a benchmark and competition that enables collaborative data-centric research, similar to model-centric research, which is the classical work. So if you worked in research in AI, you know the classical model, like ImageNet, is fixed. You try a method, I try the method, everybody tries a method, then we go to NeurIPS and we say, I got 71% on ImageNet, what did you get, right? That was the classical way we were doing research. This is called model-centric. But data-centric says, we fix the pool of the data, you iterate on the data set. So you pick a different data set, and we're all comparing each other on our data curation methods, all right? So that's the key idea. Datacomp, as I said, provides a few pools from 12 million to 12.8 billion. And we did a lot of safety work by removing toxic content, face blurring, and protecting from data poisoning attacks. I can tell you if you're interested how this is done. And then we also released the tools that train the CLIP models and the evaluation testbed on 38 benchmarks. And the participants submit either a subset of the pool and their filtering method. So people do very sophisticated ML models to do the filtering and the reweighting of the pool. And that's the innovation. And also, you can also submit synthetic data. So you can create your own images, do it using Stable Diffusion if you want, and you can add them in the mix, and we will see how well that does. So the outcome is that this data set is better than OpenAI. It allowed people to make a model better than OpenAI's CLIP. So you can see the performance here that the Datacomp data set allows you to get 79 on ImageNet accuracy and 74 on ObjectNet accuracy, which is better than what OpenAI has released. Of course, OpenAI has never released a data set. They have only released a clip model, right? So beyond that, it's an extremely useful thing if you have any retrieval problem or you're training foundation models, and it's used by many companies, including Anthropic, Apple, Meta, and many others. And it's also used for OpenClip, which is a very widely used project that's been downloaded more than 50,000 times a day, I'm hearing. And it's also used in Stable Diffusion. So we have Datacomp.ai. This is a competition page where many people are participating. And we're also doing workshops on Datacomp and Data-Centric AI in academic conferences. Conclusion, so making dataset curation a first-class citizen is kind of what we're trying to do here. And this allows us to invent new ways of doing the filtration, the weighting, and also the synthetic augmentation. And this is an extremely important area of research that's not well understood. By creating the benchmarks and evaluating zero-shot performance for many subtypes of tasks, we have learned that basically, the average performance across the tasks is truly predictive of new tasks. So it's not that one thing works for one task and something completely different works for a related task. And industry, as I said, is not releasing data sets, so it's a good thing for academia and the open source community to do. And it's also creating the standardized benchmark now for evaluating synthetic data sets. And I think a lot of the action right now is on synthetic augmentation and filtering. And this, I think, is a key part of our competition. So I will stop here and take questions. Thank you.